If you think that you'll study in an engineering college for 4 years and then you'll work for 50 years for all the skills that you need for the 50 years, that is not possible. There is a lecture on YouTube which is titled 4 and 50 Challenge. And the importance of continuing education. So now the 4 and 50 challenge, basically the bottom line is that, okay, if you think that you'll study in an engineering college for 4 years and then you'll work for 50 years and keep blaming the engineering college कि उसने हमको ये नहीं पढ़ाया, वो नहीं पढ़ाया, and then for all the skills that you need for the 50 years, that is not possible. Which means that as you go along in the career, you have to self-learn. And then that has been emphasized all over the place. कि भाई ठीक है, self-learn, continuing education, and so on. So immediately what happens? See, self-learning and so on, that lifelong process, all that is fine. But immediately the issue is this. If you look at an assembly line model of education, what we get in my classroom or in my university or institute or whatever it is raw material from lots of places. You are the raw material. Just think of it that way. Okay, you're coming from different places, you're put into one place, and some industrial process is happening. I mean, somebody's trying to teach you this, somebody's trying to teach you that, and that process goes on for 4 years. And you become a product. And that product goes out for the industry. And the idea is that the product should be industry ready. That's what industry says. Plug and play product leke aa jaiye. Give me a pen with which I can open and start writing. You give me a mobile phone so that I can just switch it on, put the SIM card, and I can start talking. So that's the plug and play model. In fact, the word plug and play, I don't know how many of you have ever tried to think why this word plug and play. Just Google it for yourself and find out why do we use plug and play. I am not sure whether you guys understand it. We understand it because in our generation, it is when it came about, plug and play. Okay. Now, the point is that the industry wants plug and play. That means they want industry-ready products. So then the onus is on the industry, that is the classrooms, to produce that plug and play model, a plug and play ready, industry-ready engineers. The issue is that on the other side, I'm just trying to explain to you the whole scenario, okay, and why we cannot produce plug and play engineers. On the industry side, if you see, there are many, many types of industries, right? For civil engineering, I mean, if you go out of that civil engineering industry, that adds to the whole problem or the whole scenario. Within civil engineering, what are the kind of jobs that you aspire for? You could aspire for a consultant's job, you could aspire for a designer's job, a contractor's job, you could aspire for a government job, which would be technical. I'm not even including the non-technical government jobs. Right? Now you say consultant. No, if you look at, that is one cross section that you take, right? If you cut the industry in another cross section, you will find that the construction and related industry is all about structural engineering. You heard a talk about tall buildings. There can be a similar talk on bridges. There can be a similar talk on tunnels. There will be a talk on roads. And each of these industries, each of these verticals require different skill set. So how many of those skill sets can we impart to you? There's a limit. Where does that limit come from? That limit comes from the fact that it's a 4-year program, 8 semesters program. Within 8 semesters, we cannot have too many courses at one point in time. We can only have 4 courses, 5 courses, whatever that number is. And that's what one college will have a different thing from the other. Somewhere you'll be asked to do 5 courses, 7 courses, whatever that number is. Now, if the number of courses we keep pushing, we'll have all these We'll want to teach 10 courses. Then the problem will be the content, whether you are able to absorb some content, not absorb some content, what is the treatment of the subject. I can finish the whole discussion on the design of a under-reinforced concrete beam in one lecture. It could be 15 minutes and then leave it to you as an assignment. Is that what we want to do? Somebody will say, no, let's explain a little bit more, explain the code a little bit more. The gentleman from the JSW said that they will expect you to know codes. How many codes do we teach you? I mean, even in the cement industry, there are so many codes that they use. So, I mean, there is this code business is a very different business. From my point of view, from an academic point of view, remember also that when we are talking to people in the class or when you are sitting in a class, some of you might aspire to become a teacher like us, which means that our endeavor will be to explain to you the real science behind it. How does concrete crack? Why do we need a certain radius of turn? What is banking? How do we achieve it? And so on and so forth. Please do one thing. You go back to your college, you go back wherever you want. When you go back to your college and when you start studying once again, think of your curriculum. So you're being exposed to a curriculum. First year you did some courses, second year you're doing some courses, did some courses, third year doing some courses. In principle, the coursework is divided into what I would call institute compulsory courses, institute level compulsory courses. That means not only civil but also mechanical, electrical, everybody does it. That could be a course in mathematics, that could be a course in engineering drawing, that could be a course in XYZ, whatever. Then there'll be, now within that institute compulsory courses, like institute-wide courses, there'll be some courses which are science, some courses which are engineering science like thermodynamics, which is a little useful to other course disciplines, not necessarily to us, fluid mechanics, and so on. Then you have department compulsory courses. That as civil engineers, the department tells you that these are the courses that you must do. Then there are elective courses, which you can choose. The institute offers them sometimes, does not offer them sometimes. They say, okay, this is a basket of 4 courses, take 3 out of them, whatever you want to do. Within the elective courses, there are 2 types of courses, at least in Kanpur, and I'm sure there are some variant of that in your universities as well. One is called departmental electives. That is, there are departmental courses, and you choose some of them in that basket. Then there are open electives that, okay, you can go outside the department and choose a course in data structures or a course in communication, right? So those are open electives. They are open to you, you can choose them. Now, if you look at a balance or you do the arithmetic, when I did the arithmetic for Kanpur, I realized that depending on how a student chooses his or her electives, the number of courses or the credits that the student does in civil engineering could vary between about 35% to about 45-47%. For about 52%, or even if it becomes 50%, I don't mind. For 45%, I don't mind. Virtually half the time goes into compulsory courses and allied courses, which we consider are important for the engineering profession. So that's why we say that, okay, look, here is a situation where we are creating a foundation, and it is for the industry, whichever industry you go to work with or the industry that hires you, to build on that. If that industry needs building software, that is, I mean, all these building is real building stuff, I mean, like high-rise, low-rise, XYZ buildings, as different from bridges, as different from tunnels. So if you're into a building kind of an environment, you need a certain type of software. They will use a certain type of software. A tunneling kind of people will use a different kind of software. They have a different set of tools. But once you understand the physics of the whole process, you should be able to pick up those tools. Now the question really is whether a 30-day or a 40-day period is good enough to learn those tools to the extent that you can master them, you know them well enough, and so on. So that is where the whole issue is. So the idea basically at that point, immediately as you join the company, is you are learning the tools and which are relevant to that particular trade. Okay, and once you mastered them, and that's what that guy said, it could take about 3 to 5 years for you to understand that. See, I mean, I'm not sure. For example, there's a contracting company and they are building a bridge, and they tell you, go to the bridge site and become a site engineer. You are just not prepared to become a site engineer. And your mason there or your barbender there, they will start telling you that this is what we do and this is how things are done. They don't know what is an under-reinforced beam, but they know how to place the reinforcement in a beam. Now, this brings me to another aspect of this whole engineering profession. See, engineering is a practice-based profession. Okay. Now, what is a practice-based profession? I'll tell you. How many of you have driving licenses? A lot of you have driving licenses, right? How many of you actually drive? I'm not sure whether the number of people who drive is greater than the number of people who have licenses. Which means, see, driving is a skill, right? You are able to drive. Now, getting a driving license is a theoretical exercise through which somebody certifies that yes, you can drive. But you can drive without that. You think that you can drive without that. So that is what it is. And then there are people who, see, when I was in Japan, I learned a new term. That was, of course, long ago. And I haven't heard that term in India. That's why I mentioned Japan here. They use a term called paper driver. Paper driver is a guy who has a driving license but cannot drive. Because to be able to drive, you have to, driving is a skill. It requires experience. You have the learning, and then you drive, and then suddenly you have to apply brakes. You can be a good critic. See, that you have to be a bad. These are all critics versus actors. A good critic need not be a good actor, right? So there is these kind of issues involved. Now, where does engineering come into this? Engineering, how many of you believe that engineering fits into this discussion or no? Engineering is purely science, theory. It is not. It is purely practice. And that is where what my issue with a lot of designers is. That they can design, they design. And what is design? Design is another animal altogether. And that's what the industry tries to teach you. We don't try to teach you that because we don't have the time. It's not that we cannot, but we just don't have the time within that one course on RC design or steel design. See, design is meeting scientific principles of demand and supply, expectations and so on, accepted behavior. What is a deflection? Accepted. See, deflection to hoga. If you load a beam, there will be deflection. How much is acceptable? It's a matter of professional judgment. L by 500, L by 400. Codes can be revised. So somebody says you should have knowledge of codes. I'll teach you knowledge of IS, let's say 4, 5, 6 of 2000. Suddenly 2026 will come. There is a 2026, so aapko pata nahi hai. Then that means I have to teach you the principles underlying it, and so on. So I don't think code-based education is a great idea. Okay, just to explain to you that we have our limitations, and we know that you're not industry ready, but we consciously perhaps choose not to create industry ready products, because industry ready product means that we'll create it for one industry, not for the others. We would rather have you prepared in a more generic sense. That said, what has changed in the last several years is the fact that you have the opportunity to teach yourself. Now, this whole information revolution if somebody teaches you RC design, somebody teaches you some sustainability related stuff, some water supply design, the instructor may be good or bad. See, the instructors are also not great instructors all the time. So we understand that. See, 5 fingers, barabar nahi hai, right? So not all instructors are great. Some will be very good, some will be very bad. Fine. You decide as early as possible what you want to do in life. And then try to move in that direction. Keep your curriculum in mind. Now there is a lot of information available. You know your curriculum to begin with. If you want to become a structural designer, Umesh Joshi ji was disappointed that only 4 of you raised your hands when he asked, serious structural design kaun karega? Kaise karenge? Who's interested in doing that anyway? So if you want to do that, you realize that your curriculum does not have a course on high-rise buildings. Look up material. Try to teach yourself. By and large, you can talk to your faculty members that, okay, I'm trying to do this on my own. Can you help me a little bit outside? Try to do that. Courses like the NPTEL are available to you. So you choose courses, any number of domain. Because see, my understanding is, I've been a student and I understand that elective courses are not necessarily chosen only based on your interest. They are also chosen by who's teaching them. I mean, you may love structural engineering, but if suppose that guy is teaching it, chhod do yaar, usme to C aa jayega. So you have a very clear idea that you don't want to compromise on your CGPA. So that's fine with me. I mean, I understand that. So you cannot just say, yeah, usme bahut kaam karna padega. So either way. So try to learn on your own. Economics, if you want to learn. These are the kind of things that you need to pick up, and you will be better prepared. And NPTEL kind of certification, because they have exams associated with it, will become recognized, and that is what the industry has to understand. And I think the industry will understand that, okay, apart from your BTech or BE, whatever you're doing, if you spent your time doing these number of additional courses which has given you an exposure in whatever subject you choose, I mean, communication, software design, data structures, X, Y, Z. But don't spread yourself too thin, because the moment you spread yourself too thin, the whole thing is gone, right? So that is where the issue is. Now, another thing which we keep talking about is the salary expectations, and the salary is low and salary is high and so on and so forth. It goes back to the original discussion that you are not site ready, and therefore all the salary that is being paid to you is virtually an overhead to the company. The company is not earning anything on you, and therefore you'll have to live with the fact that till such time as you become productive to the company will not pay you, because it's all overheads, basically overheads. And lastly, I'm reminded of another thing which is important for you to understand from the construction industry's point of view. And civil engineering is all about construction. I mean, like, at the end of it, whether you design, whether you do whatever, it's all about construction of a facility, whether it's a building or a bridge or a tunnel or a road, whatever, XYZ port. We are a very conservative people. Conservative means, and why are we, anybody can tell me why are we conservative? We don't believe in innovation. See, even though this is centered around innovation, and we'll try to see what innovative ideas you have. But we are not a very open profession as far as innovations are concerned. We are conservative because, by and large, a lot of lives are at stake. We cannot let you do things without proper approvals, without it being laid down in certain documents, without it being kind of properly vetted. You cannot say, this software I'll write this way, or we'll do some editing. We cannot just allow you to do that. We would like you, even if there's an innovative idea, why do we put the shuttering like this? Why can't we do the de-shuttering in 7 days? Kyun lagana chahiye? 3 days mein kyun nahi kar sakte? Fine. and so on. There are hundreds of such examples that we can come up with. So we are a very conservative people because of the huge amount of social risk which is involved, the huge amount of capital which is involved. I mean, if you were doing a bridge and you want to play around with it, it's not a Lego toy. It's not a war game going on there, right? In fact, those of you who are some people within the defense forces, you understand that. War is not a game. People are getting killed in that process. People are fighting hand to hand, right? So it's not a game. We cannot just say, let's move this battalion here, this regiment this way, tank laga dete hain, artillery fire kar dete hain. It's not a game ki hawa jahaz chal rahe hain. No, aisa nahi ho raha hai. Real people are involved. So that is what the whole thing is. Some professions you can play that game a little with lesser risk. In our profession, we cannot do that. We do not do that, and I think for a long time we will not do that because it's very difficult, and that will take me to that, if you think really, can take you into a very different kind of discussion where you say, okay, EPC mode of contracting, who does the design, who does the construction, who takes the responsibility, liability, guarantee, warranty, all kinds of stuff. So there is a lot of complex interrelationships, complex interdependencies which determine this whole relationship between the employees, the employers, and potential employees, which is people like you, creators of those employees, which is people like us, understanding the industry needs. So we understand industry needs. It's not that. It's not as if we don't understand that an industry needs a car with 4 wheels, 4 doors, 2 wipers here, another wiper at the back perhaps, and so on and so forth. But we just can't do it. So we say, अच्छा ठीक है, ये गाड़ी है, 2 पहिए, 2 दरवाजे, बाकी अपने आप लगा लेना. So they kind of have to do that. That's where we have to have a dialogue with them. And if you want it, you can build your own doors and windows with the kind of understanding which you now have through your understanding of the curriculum, what you want to do. Okay. I think that's where we'll close the discussion. Thank you so much.